Hey everyone, this is Michael Angel, and you are watching My Human and Me.
We're talking about highly capable models that are openly available for anyone to download. Models like Llama from Meta, DeepSeek, Qwen, and Mistral. Now, if you read mainstream tech coverage, this shift is almost always framed as a sporting event.
Oh yeah, the whole us versus them angle.
Right. The headlines say, open source is catching up to OpenAI, or the big tech monopolies are losing the intelligence race to open weights. But I have to push back on that. Isn't this framing fundamentally misrepresenting the mechanics of what is actually happening?
It absolutely is.
Why is the intelligence race the wrong lens for local AI?
Because if you view this purely as a benchmark race for absolute maximum capability, the massive closed-source cloud models will likely always maintain a slight edge.
They just have more money and more computers.
Exactly. They are backed by compute clusters that cost tens of billions of dollars. You simply cannot fit the computational depth of a frontier model into the physical RAM of a laptop. The real shift here isn't about achieving maximum intelligence. It is entirely about shifting the locus of control.
Control. Okay, let's dissect what that actually means for a listener. So I think people underestimate how huge that is.
Think about it. When you use a cloud API, you are renting access to a black box. You are bound by their terms of service, their acceptable use policies, and their pricing tiers.
Right.
If the company decides to update the model overnight and it suddenly breaks your specific workflow, you have zero recourse. If their servers experience an outage, your application goes down. And most importantly, every single piece of data you send them is processed on their hardware.
They see everything.
But when you download the weights of a model like Llama or Mistral and run it locally, the paradigm completely inverts. You own the intelligence, it executes on your silicon.
The privacy implications alone are staggering. Just think about industries dealing with highly regulated or deeply sensitive data.
Oh, it changes everything for them.
Like a lawyer reviewing confidential litigation strategy, or a hospital system analyzing patient medical records, a hedge fund parsing unreleased financial data. Ethically and often legally, they literally cannot pipe that data through a third-party API endpoint controlled by a mega corporation. It's an unacceptable data leak risk.
Exactly.
But if they can download a powerful open-weight model, disconnect the machine from the internet entirely, and run the analysis locally on a secure server sitting in their own building, they gain the massive productivity boost of AI with zero privacy compromise.
It solves the data sovereignty problem perfectly. But it also drastically alters the economics of experimentation. Well, if you are a developer building an application that needs to analyze, let's say, 1 million user reviews a day to extract sentiment, paying a per-token API fee to a cloud provider for every single inference would bankrupt you almost immediately.
Right, the costs add up fast.
But if you self-host a local model, your marginal cost of inference drops effectively to the cost of electricity powering your hardware.
That's wild. But let's get into the mechanics of how this is even physically possible, because this is the part that still blows my mind. 3 years ago, if you told a machine learning engineer that regular people would be running highly capable LLMs on standard consumer hardware, just a high-end laptop or a gaming PC, they would have laughed at you.
They would have thought you were joking, yeah.
Full-scale models require massive clusters of H100 GPUs just to fit the parameters into memory. So how are people running Llama on a MacBook?
The breakthrough isn't just that the open source models got better, it's that the mathematical compression techniques became incredibly sophisticated. Specifically, the widespread adoption of quantization.
Unpack quantization for us. How do you shrink a brain without lobotomizing it?
It's a great question. So, when a model is trained in a data center, the weights, the billions of mathematical connections between the neurons, are typically stored in highly precise 16-bit or 32-bit floating point numbers.
Lots of decimals.
Lots of decimals. And this precision takes up a massive amount of VRAM. A large model might require 140 gigabytes of VRAM just to load, which means you need multiple high-end GPUs linked together.
Okay.
Quantization is a mathematical process of reducing the precision of those numbers. You basically compress the weights from 16-bit down to 8-bit, or even 4-bit integers.
So you are literally just rounding off the decimals of the neural network's memory.
Essentially, yes. You are mapping a highly granular range of values into a much smaller, coarser set of bins. Now, intuitively, you would think that rounding off the math of a neural network would destroy its intelligence, right?
Yeah, you'd think it would just become stupid.
But researchers discovered that these models are incredibly robust. You can aggressively quantize a model down to 4-bit precision, shrinking its file size by 70 or 80%, and the model only loses a tiny fraction of its actual reasoning capability.
Wow. That is the aha moment right there. Quantization is what allows a 70 billion parameter model, which normally requires a massive server rack, to be compressed into a file small enough to load entirely into the unified memory of a modern laptop.
Exactly.
And the tooling around this has become so frictionless. We have software layers like Llama or LM Studio or OpenWebUI. You don't need to know how to code in Python or manage dependency libraries anymore.
No, it's basically plug and play now.
You literally download an app, click a button that says download Llama, and within 5 minutes you have a local private chatbot running entirely on your own silicon.
And that shift to local execution brings us to the massive hardware pivot happening right now. Because if the computation is moving from the cloud to the edge to your laptop and your phone, the traditional architecture of consumer devices has to change. CPU and GPU architectures weren't explicitly designed for the continuous matrix multiplication required by neural networks. Running an LLM on a standard CPU is incredibly inefficient.
Right. If you try to run heavy inference on a standard CPU, it will throttle, the fans will spin up to sound like a jet engine, and it will drain your battery in 30 minutes. It's like the classic joke of your laptop's cooling system quietly filing a formal complaint with HR.
Yeah, the hardware is literally screaming for help.
Yeah.
You need dedicated silicon.
Which is why the entire hardware industry is racing to integrate NPUs, neural processing units, directly into consumer chips.
Exactly. An NPU is a specialized piece of silicon engineered specifically for the highly parallel tensor math required by AI models. It doesn't process general graphics like a GPU, and it doesn't handle sequential logic like a CPU. It just crunches matrix math with extreme power efficiency.
So the local AI rebellion isn't just a software movement, it is forcing a physical redesign of the computers we buy. The transition from the model lives in the cloud to the model lives on my local NPU is happening at lightning speed. It's no longer just an experiment for hackers. I mean, people are running quantized models on their daily commutes to benchmark them. The genie is out of the bottle.
Plan accordingly. It's a fundamental shift.
But, taking AI off the cloud and into your local machine is just one way the ecosystem has split. The other massive split is that the entire ecosystem is moving out of the text box entirely. We're entering the era of specialized media generation images, video, and audio.
This is where things get very visual and very complicated.
Right, and the architectures here are fundamentally different from the language models we've been discussing.
This is the moment where AI starts looking a lot less like a website that you visit and more like a capability that you own, which changes the psychology completely. Because if the intelligence runs locally, your data stays with you, the system works offline, no company can throttle your usage, no API price suddenly changes overnight. Nobody's quietly changing the model behavior while you sleep. That's a radically different relationship to software. And I would add that offline models are going to change dramatically over time as well, which means they could probably be multimodal and have shifting based on your needs as well. You might have a model that shifts down in the CPU use if it recognizes that you need just a simple email reply. It might shift up if that email looks complicated and it needs to maybe even do a search through your other mail. I just don't trust it for that kind of thing. Okay. So having that relationship with basically private AI, which there's no such thing, but fancy that, that's a radically different relationship to software. Honestly, I think a lot of people still underestimate just how dramatic this shift is going to become in the AI landscape. Because historically, major technology trends move from centralized to distributed, mainframes to personal computers, cable TV to the internet, cloud software to local AI inference. This is exactly why open weight models matter so much strategically.